So, what do you think gives a scientific theory its power? I mean, the obvious answer is that it's got to be right? You just pile up evidence until it's proven true. But what if I told you the real strength of a theory comes from how much it risks being completely and totally wrong? Yeah, let's get into this, because it's a wild idea that's at the very core of science. Just think about astronomy versus astrology for a second. They both look up at the stars, they both make predictions about things. So what's the real difference? I mean, why is one considered a science and the other isn't? This is actually a classic puzzle. They call it the demarcation problem. And the answer is probably not what you're thinking. You see, the key isn't about racking up confirmations. An astrologer can always find events that seem to fit their predictions if they're vague enough. No, the real dividing line is a concept called falsifiability, and it flips the whole script. It's not about proving you're right. It's about having the courage to be proven decisively wrong. And that's the central idea we're digging into today. A really powerful scientific theory isn't some mushy, vague idea that can explain anything and everything. Nope. It's one that makes such bold, specific claims about how the world works that it's constantly in danger of being shattered by a single observation that doesn't fit. Its power comes directly from its vulnerability. So what exactly is this falsifiability thing? Well, a truly scientific statement has to draw a very clear line in the sand. It has to divide the entire universe of things that could possibly happen into two buckets: the stuff it allows, and, this is the important part, the stuff it forbids. Okay, let's put a formal name on it. That bucket of forbidden observations, those are called potential falsifiers. These are the specific things you could go out and look for that if you ever found one, would just completely wreck the theory. They're the things a theory screams from the rooftops cannot happen. Now, here's what's so cool about this. Think about where a theory's information actually comes from. It doesn't really tell you much about the stuff it permits. I mean, those are just things that don't break the rules. The real meat, the actual claim about reality, is in the things it prohibits. That's the guts of the theory. So this whole idea of being risky, of being falsifiable, it's not just some philosophical quirk. It's a direct way to measure a theory's horsepower. The more a theory risks being proven wrong, the more empirical content it has. In other words, the more it's actually telling us about how the world is put together. All right, let's follow the logic here step by step. A theory's actual assertions, its real claims, are only about its potential falsifiers. And what it's doing is asserting that every single one of those potential falsifiers is false, that you will never ever find them in the real world. Which leads us to this. And this is the brilliant part. A theory that prohibits more things, that has a bigger list of no-nos, is actually telling us more about the world. Its boldness is measured by what it forbids. Okay, so you might be wondering, how do you actually make a theory riskier and therefore, better? Well, it really boils down to three main strategies. You can increase its universality, so it applies to more stuff. You can increase its precision, making it way more specific. Or you can increase its simplicity, so it has fewer moving parts. I know this can feel a little abstract, so let's make it super concrete. We're going to look at a simple example with planetary orbits, and we'll pit three competing ideas against each other to see which one is the most scientifically powerful. So here are our three contenders. Statement P is the boldest. It says all heavenly bodies move in perfect circles. Q is a bit more cautious, saying only planets move in circles. And R is less specific about the shape, saying all heavenly bodies move in ellipses, which, includes circles as just one special type. So, just take a second here. Which one of these statements do you think is the most powerful? Which one is sticking its neck out the furthest? Remember, the riskiest theory is the one that has the most to say. Okay, let's break it down. First, P versus Q. Statement Q only makes a claim about planets, but P applies to everything up there. Planets, comets, asteroids, the whole shebang. So if you find even one comet with a non-circular orbit, statement P is toast. Statement Q would be totally fine with that. So P forbids way more, which makes it stronger. Now, let's look at precision by comparing P and R. Statement R is pretty generous. It allows for any kind of elliptical orbit, long and skinny or almost round. But P is way more picky. It demands a perfect circle. That means P automatically prohibits all those slightly squashed oval shapes that R is perfectly happy with. Again, P forbids more, so it's a stronger, more precise claim. So, the conclusion is crystal clear. Statement P is the heavyweight champion here. It's the most universal and the most precise. It makes the boldest possible claim, which means it has the biggest target on its back. It's the most exposed to being proven wrong. And in the world of science, that's what makes it the most valuable. All right, let's zoom out and lock in the big takeaway from all of this. The whole point of science isn't to play it safe, to come up with vague ideas that can never be pinned down. The goal is to do the complete opposite. This quote just nails it perfectly. The more things a theory rules out, the bigger and more profound its claim is about the true nature of reality. Its power is defined by what it says can't be. So, if you're going to take anything away from this, let it be these points. A theory's true power is its testability, its falsifiability. The more it forbids, the more information it's giving you. That's why good science is all about making bold, precise, and super risky claims. When it comes to science, being riskier really does mean being better. And that leaves you with a really powerful new tool for your own critical thinking. The next time you come across some big claim, doesn't matter if it's in the news, online, or from a friend, don't just ask, what does this explain? Instead, ask the much better question. What does this forbid? What observation, if we found it, would prove this whole thing wrong? The answer to that question, that's where you'll find its true strength or its weakness.